So now I want to zoom in on the factor theorem. And the factor theorem is just a special case of the remainder theorem. The factor theorem, so if f of a is equal to 0, then x minus a is a factor of f of x. Alright? So remember, when you find f of a, what f of a gives you is the remainder. Alright? And if the remainder is 0, then obviously the divisor is exactly divisible. Alright? So let's look at some examples with this. So given that x minus 1 is a factor of x cubed plus px minus 6x plus 3. What is the value of p? So given that x minus 1 is a factor of this expression here, what is the value of p? Alright, so if x minus 1 is a factor, alright, it means that f of 1 is equal to, f of 1 is equal to what? F of 1 is equal to the remainder. But f of 1 is equal to the remainder. But since it states it's a factor, then the remainder is 0. So f of 1 is equal to 0. Alright, so 1 cubed, which is 1, plus px. So px, that's what? 1x. 1p, sorry. X is 1, so 1p. Minus x, 6x, 6 times 1. Plus 3 is equal to 0. So f of 1 is equal to 0, and here's f of 1. And we can transpose now, so p is, let's group everything over here, positive 6, minus 3, minus 1, so the value of p is 2. Let's look at another problem. Alright, so here we have a problem. The expression x cubed plus px squared minus x plus q has x minus 5 as a factor, and the remainder of 24 when divided by x minus 1. What are the values of p and q? So we are told that x minus 5 is a factor. Therefore, if x minus 5 is a factor, f of 5 will give you a remainder of 0. And also, we are told that when divided by x minus 1, I have a remainder of 24 when divided by x minus 1. So f of 1 is equal to 24. Alright, so f of 5, let's find f of 5. So f of 5 has 5 cubed, which is 125. Let's put everything, so 5 cubed. Alright, plus p times 5 square. Replace the x with 5, right? Minus 5 plus q is equal to 0. Let's calculate this now. So 5 cubed, that's 125. Plus x squared, that's 5 squared, so 25p. Minus x, so it's minus 5 plus q is equal to 0. Let's see if we can group constant. What we have here is 25p plus q And for the constants now, here I have 125 minus 5, that's positive 120. That's equal to 0, right? And we also know that f of 1 gives 24, because when you're dividing by x minus 1, the remainder is 24. So f of 1 would be 1 cube, which is 1, plus p times 1 square, which is just p, minus x, so minus 1, plus q. And that is equal to 24. Which means that 1 take away 1, that's 0. So p plus q is equal to 24. Let me just fix this up a little bit. So if I subtract 120 from both sides, what we'll have is 25p plus q equal minus 120. So we have our equation here. Call this probably equation 1, good. We have another one here, so we have a pair simultaneous. So obviously, seems that we can subtract them. So let me just use a different color here. So here we have p plus q. We have p plus q equal 24. Now we have 25p plus q equal negative 120. So if we subtract, and we subtract because we recognize if we subtract, the q will be eliminated, right? So this is p is 1p, right? So 1p minus 20, this is 25p, right? So 1p minus 25p, that's negative 24p. Q take away q, that's 0. And this is 24 minus 120, right? So it's 24 plus 144. 24 plus 120, which is 144. Continue. So it means that if I can divide both sides by minus 24, so minus 24p equal 144. I divide both sides by minus 24. So p would be equal, so that into that, so that's 1. So p would be equal to 144 divided by minus 24. That sounds like 6, so minus 6. So p is minus 6. But remember, we know that p plus q, recall p plus q equal to 24, right? We know p plus q was equal to 24. Right? Here. So we are told that p is what? Negative 6. So negative 6 plus q equal 24. So add 6 to both sides. This what 6 will become 0. We'll add 6 to the right hand side. I'll group this minus 6 with that. 24 plus 6. So the value of q is 30. So q is 30 and the value of p is minus 6. I just want you to be aware that sometimes when they ask these questions, instead of saying x minus 5 is a factor, they say the function here is exactly divisible by x minus 5. It's another way of saying that it's a factor, and also that saying the remainder is actually 0. Good? Let's look at factorizing these cubic expressions. Next video.